All right, so we are going to switch to the next part of the event. So we've heard from the customers, which I thought was very interesting. Thank you very much, guys. We are now going to have a presentation by some really cool startups in the data and finance space. Again, a mix of market finance and consumer finance. And for those who come here regularly, we're sort of switching to the regular format, which is that each of the presenting companies are going to present for 10 minutes, back to back, and then we're all going to bring them to a panel format where you guys can ask as many questions as you want. And with that said, John Fawcett, who goes by Foss, who's going to talk about Quantopian. Thank you very much.
Thank you. Is this the right device? We'll find out, yeah. My slides are a surprise. So. Hi, I'm Foss. I'm going to try to stay up on the stage here so you can actually see me. If I fall down, someone will take over. I'm coming down from Boston. The name of my company is Quantopian. And we're focused on the quantitative finance workflow, so the creation of trading algorithms from the moment of inception, when a quant analyst has an idea, all the way through trade execution. And so I'm going to talk tonight about quant finance. It's a short presentation, so I just wanted to make some, just a few points, tried to choose some compelling topics. And the wrong clicker. There we go. All right. Quant finance in one picture. So I chose this image because I think quant finance is kind of remarkable. I mean, this is Bobby Knievel, the Lesser Knievel, jumping over the Grand Canyon. A highly engineered stunt. And the thing about quant finance is there is an incredible amount of work that goes into the infrastructure and the delivery of all the tools that the quant analyst needs in order to conceive of an idea and then deliver it. And it's a lot like this. It's a leap of faith over an enormous challenge. And what's amazing about this isn't, unlike this jump, the creation of all this infrastructure isn't done only once. It's done by every individual firm out there. Every single quant firm, almost every single quant desk recreate many of the same technologies and the same platform to solve very, very similar problems. And my theory on why this is the case is that the entire industry is in this shroud of secrecy. It's not allowed for quants to talk publicly about the work that they do often, or almost always. It's very, very difficult for them to make connections with other quants. And as a result, they work in isolation. I think there's a perception of value, that they're protecting value by remaining secret. But I actually think they're doing a tremendous disservice to their own profession because not every single piece of the infrastructure is really proprietary. So one other problem, in addition to kind of reinventing this massive infrastructure, the workflow today for an algorithm, for an idea to make it all the way into trading execution, it'll start with a quant researcher, someone with a PhD, someone who might have studied physics or statistics, people with brains very different from mine that can envision ways to have insights into the data, into the markets, and make hypotheses about how to profit from them. And then there's a long chain of delivery from that person all the way down to someone like me, a systems programmer who's going to implement that idea and make it into a trading algorithm and actually go out into the markets and trade. And there's a huge gap between the beginning of the process and the end of the process. The beginning of the process, we're dealing with very large quantities of static data. We're looking at it all at once, right? So it's batch-oriented. It's using languages like R and MATLAB and doing deep analysis. And then by the end, it's event-driven. So there's just a huge gap from the beginning of the process to the end, a lot of handoffs, and a lot of risk. Delivery risk, I should say. So I've been speaking mostly about the professional side of the industry. I wanted to change gears a little bit and talk about the individual side. The thing about the finance industry is there are wonderful real-time systems that have been under development, primarily here, for the last 30 years to get data to the end customer with as little latency as possible. And humanity, by and large, has succeeded at doing that. Real-time data is so ubiquitous that it's free in most cases. And we're down to the point where we're paying for the tiniest fractions of time that's in latency. But the thing about finance is all of this focus on real-time data, on the current data, has created an infrastructure that really isn't yet mature in dealing with deep time history. So this is just a really simple example. Anyone who's ever built any historical analysis knows the horrors of corporate actions. So this is sort of like a tortured stock. IAC on the same day went through a reverse split and a divestiture of Expedia. And so in this case, Google actually handled the split properly, but not the divestiture. And so there's this discontinuity in the data for what is supposed to be a fully adjusted time series. So you can imagine if you're an individual with a Sparkman idea, maybe you're a postdoc at a university, or you're a data scientist at a consumer company. You think to yourself, oh, I'd like to play around and see if this works in the markets. Let me see how I do that. And then you run into a problem like this, which is not the most exciting problem, but it's very, very important and has to be correct. There's just a huge amount of work to get to the point where you actually do the creative part of the process. And so there's a need to eliminate that. And for people who do this individually, it's requires an incredible amount of tenacity. It's usually 6 to 12 months of really bootstrapping an infrastructure, doing the kind of work that professional software engineers enjoy doing before they get to the part that's really exciting. And the last problem I wanted to talk about, who doesn't love the Dos Equis guy? The funny thing about this is it's so hard that it's actually really expensive. And there's a lot of people who believe that just shipping the software into production is literally a more cost-effective way to solve the problem. Let's just trade this on a small book and see what happens, rather than going through and doing all the historical analysis, because there's so much effort required to get to the point where you can actually do deep history analysis. And so, as a result, there's a lot of testing done in production. I myself have tested in production. Okay, so that's a setup for the problem. There's a huge amount of work to create this platform. And Quantopian, we want to deliver that platform in as simple a package as possible, which you cannot see on the slide. So the first thing is we're browser-based. So if you have an idea, instead of going through that 6 months of creating the infrastructure, you come to our site, and on average, about 1 minute later, you have an algorithm and you're testing it. Another thing I'd like to mention is our entire system right now, we've been around for about 6 months, so our system isn't fully developed yet, but already we have about 40,000 lines of code that comprise the system for doing the historical simulations. The typical algorithm is somewhere between 100 and 150, right? So granted, lines of code aren't a measure of productivity, but you can see just a huge disparity between the work that we do for the system and the creative side of things. Okay, we are a coding environment. If you come to Quantopian and you want to make an algorithm, you're going to have to write some code. Usually at this point when I'm starting the company, people say to me, what are you, nuts? You have an internet website and you want people to show up and start coding? I do. And the reason is the market out there, first of all, I'm a huge proponent of coding in school at early ages. I think this is a life skill. It's quickly becoming non-optional. It's pretty hard these days to find someone under 18 who hasn't written some piece of software. And so I think the world is changing very, very quickly. Does anyone know who this is, by the way? Yeah, rock star scientist. So the market's getting bigger. Already there are 40 million, I should probably explain who this is. This is the flight director for the Mars Curiosity rover. And he has single-handedly made being a scientist very cool. So there are 40 million STEM professionals. STEM stands for scientists, technology, engineering, and mathematicians. So these are people who are scientists for a living. That's a worldwide number. I see that number getting bigger. And when you talk to scientists about working with data, what they want to do is they want to get their hands in the data, and that means writing code. And so that's the interface that we're giving to them. Okay, so I was thinking, demo, no demo. I went no demo in screenshots and funny pictures. So this is a capture of our of our development environment. As you see, you type code in, and what we try to create is a really tight cycle. So if you remember the picture in the beginning of the long, month-long handoff cycle to go from inception to trading, the new picture is in one screen with one person. You write the code, we do all the functional testing for you, and then we run a simulation. And so the data scientist is getting real-time feedback, a kind of continuous integration for the data scientist, so that as they're writing their, in this case, trading algorithm, they get feedback. And this has been optimized to run as fast as possible so that you can actually code and test as you go. Okay, so the heart of our system is a backtester. It's called Zipline. I personally poured about 12 months of my life into it. I'm very proud of it. I love it. There's a bunch of other guys that have been working on it with me. And it's the kind of the best software I've ever made myself, and we open sourced it. And we're supposed to be a company. So at this point in the story, people usually say, what are you, nuts? You took the most precious IP that you had and you open sourced it. And we did. And the reason we did is my philosophy with open source software, there's a lot of good things, right? There's a lot of giving back to the community and everything like that. But from a competitive standpoint, if you are a software vendor and you're making, a piece of proprietary software, the generalizable pieces, it really behooves you to make that open source and get it into the marketplace so that it can become a standard. And when it comes to backtesting, I think one of the most important missing pieces in the industry, this gets back to the secrecy, is a standard, right? There's no way to compare one fund's backtest to another because in addition to the algorithms being black box, the backtester is black box. So Zipline is on GitHub. You can find it at zipline.io if you want to check it out. That's it. Thank you.
Thank you very much. We'll do questions. We'll bring everybody on stage after that, and we'll do questions.